Hi, friends. Welcome back. Greetings, good evening, and let's resume our discussions on Python programming. We've started understanding the features of Python programming, the history and the features, of course. These features are important. It is open source, it is free, it is independent of operating system. It is also known as high level programming language because it is English like language, hence, it's easy to read, write, and maintain. The Python programming language can be used to build anything. So it's basically a general purpose programming language. It's not confined to any one specific area. It is an interpreter based programming language. Because of it, the programs that we write are directly getting executed. So, from a development perspective, you will know what code is actually getting executed when you are writing the program, right? So, as is, it gets executed. Then we are also having the interactive programming capability where you will execute one line at a time. And it is dynamic. You can keep developing the program one by one, line by line, by executing one line, understanding what is the output, and then dynamically you can decide the logic while the code is getting executed. Then it is also having the scripting capability. It is not just interactive programming. Then it is functional oriented and object oriented. Both capabilities are there. So it is not just the traditional programming language capability, which is called as OOPS, but it also has this functional capability. And thanks to this capability, there is a lot of reusability. Okay, and because of all this, there is a huge list of repository where we can actually try and leverage on codes which were written by somebody else. We just have to reuse them. And then we have modularity. Modularity basically means you can split down the code into smaller pieces so that parallel everything can be getting executed. Then we talked about variables. Variables are nothing but the memory pointers, or you can say these are the identity that we create to the memory locations where we try to store our data. The variables should follow specific properties when we are creating variables, when we are trying to label our data or data which is stored in the memory. Those labels that we are providing or we are creating should follow certain properties, and these are the properties. Should always start with letter, though it can have alphanumeric. That means I can have names, letters and numbers, but it should always start with letter, not with number. And Python is case sensitive language. So variables which are case sensitive, right, they have to be treated separately. For example, A is separate, capital A is separate. They are completely different in Python. You cannot use any of the special characters like star symbol, dollar symbol, hash, right? Everything has a specific meaning except for this underscore. You can use underscore. And there are a bunch of other keywords which are predefined, which we cannot use. Right? So these are some of the standards of your Python programming language variables, which we need to remember. Then when we try and load the data, Python has this special feature, which is it automatically interprets what is the data that it is getting stored. And what is the data that is stored in the memory? Sorry. Python is a memory-based programming language. Memory-based programming language. That means anything that we are trying to execute first goes and sits in the memory. Whether it is data, whether it is code, everything goes and sits in the memory, and in the memory, the operations happen. Okay, so we have to be very careful with utilizing the memory. Memory management has to be very, very carefully, right, drafted here. We need to plan to ensure that our memory is clean as much as possible, because we need large memory for Python to do those computations, right? Unnecessarily we keep dumping data into it, and right, unnecessary data into it, and if our memory is getting occupied, then you'll not have free memory for doing computations. Okay, so we have to keep memory as free as possible, sessions memory, that is. Now what happens is, let's say if I say x is equals to 10. If you remember, I talked about the traditional programming language in my last session. So what happens, the steps? We first define a variable. Then we just then we declare that variable for specific data type, or declare or define, whatever that order is. Basically what I'm saying is, you need to first tell what is x. You're saying x is a variable. Then we are saying x can take only integers. After these two steps, we assign the data. What data we are assigning? Whatever we are defining here, right? In these two steps. So if I'm defining it as an integer, then x can take only integers. It cannot take any other right, decimal values. This is how traditional programming languages work. So we have to first define the data or data type. Okay, we have to first explicitly tell. Then we load the data, the same type of data. But in Python, it is right, automatically interpreting or inferring. We call it as inference, the schema. Schema is nothing but data type. So in Python, if I say x equal to 10, there is no declaration of variable, defining of the variable, assigning the values, etc. It is just directly assigning the value. Single step. What happens now is, depending on this data, whatever we are assigning, right? Python interpreter or Python kernel will look at this data and it understands that this is numeric. Start, right? This is to start that it is a number. It detects that it is a number. In the number, it will then see that there are no decimals, hence it will declare it as an integer. But if it is seeing some decimals, then it will declare it as a float. Right? So this way, it basically automatically detects the data type. But remember, we are starting with primitive data types. Primitive means the basic default data types for any programming language, which are integer, float, complex numbers, Boolean numbers. Boolean is basically nothing but 1, 0 or true, false. Okay, in Python, we call it as true, false. And then we also have character data, non-numeric. This is non-numeric. Okay, so this is basically how the data types are automatically inferred. We don't have to manually, as a developer, we don't have to explicitly tell Python that, okay, this is data that we are uploading, not required. It will automatically detect. So let us now try and understand these things, variables and the basic data types. And of course, I have also talked about operators, forgot. I'll talk about operators also, and then we will go to the code. Okay. Now, when we talk about programming language, we basically need right, some kind of operations to be performed. Okay. So first is data. Right. In programming language, what we will have? We will have data. We will have, of course, syntaxes, language syntax, so that we can write some instructions. So language syntaxes will be there. Then we will have data. And we also have some kind of operations to be performed. And for that, we need to write code and all that. Right, to write the operations, we basically use that specific syntaxes. Now, there are certain operations which are mathematical operations, which are very easily done thanks to the shortcuts. For example, in mathematics, if I have to add two numbers, 2 plus 2, right? This is the symbol that we write. Now remember I said in variables we cannot use any special character because every character has its own definition, its own meaning. So you can say Python is something like a calculator to start with. In calculator, all these symbols, operators are predefined, right? So same operators are there in Python also. Here we will talk about these simple mathematical operations as arithmetic operators. Arithmetic operators. We'll have plus, minus, multiplication, division. In Python, we have additional things called as floor division. This is called as floor division. Then we have modulus. This gives us the remainder. And then we will have double star. Double star is like cap, exponent. These are the basic mathematical operations that you see. And these are called as arithmetic operators. Similarly, when we are trying to do some kind of arithmetic operations, right, or any mathematical calculations, not just these, but there will be some other operations also that we probably need to perform, like comparison. We call them as relational operators or comparison operators. So here, if I say double equal to, then this is to check whether 2 is equal to 2 or not. Then we have not equal to. Similarly, we have greater than, less than, greater than or equal to, less than or equal to. Right? Very, very simple comparational operators or relationship operator. Now here we are putting two equal to symbols. Fine. But what happens if I put single equal to? I used already this x equal to 10. I've used this equal to symbol here already. Right? So this is called as assignment operator. So we are assigning the value which is on the right side to a variable on your left side. So operations in Python happen from this right to left. Coding we write from left to right. Right? When we read it, it is left to right, but the execution happens from right to left. Okay, execution happens like this. Right? Similarly, we have identity operator, then we have membership operators, etc. Now we'll talk about those things also. Let us now go to the code part. Spider is not loaded yet. Okay, so before starting all this, I forgot. People who are not familiar with Python, who are basically here for the first time looking at Python programming, then see Python programming language is basically like this. Okay, it's a open source. It's an open source programming language, and this is how it looks like. If you're writing the Python program, this is how you have to write, and in a command line interface. We call it as CLI. It's a very easy direct download is available. This command prompt looking like interface is what you will get. This is called as CLI, command line interface. Okay, this is the default option, and the latest version of Python that is now available is 3.14.0. Okay, but we will not use this. We will not use this. What we will use is Anaconda. Anaconda.com. If you already have installed this one, fine. If not, then you might want to install it. So here you will see free download option. Now this Anaconda is a company which provides a comprehensive software which is like packaging a lot of things. In that package, Python is one main tool. So it's like Python core, Python that we take. And on top of that, we add a lot of other plugins, tools, etc. And it gives you a centralized controlling platform, right? For all these things to work together. Anaconda is that software. It's absolutely free for an individual user, but if you are a corporate and if you want to go ahead to have license, that is support, then you can pay premium and upgrade your free software. So it's a downloadable file. It is close to 1 GB approximately here and there. Once you install it, depending on operating system, of course, if I click on this, it will redirect to this location where you need to sign in. Free community access. Okay, you basically sign in or sign up. All you need to do is add your email ID and basic details, and then it will give you the downloadable version. Depending on what OS you have, you need to pick up the respective software and download it. Okay. Now, once you install this, you will get something called as Anaconda Navigator. There are many ways to use Python. There are many IDEs. IDE stands for Integrating Development Environment. Integrated Development Environment, IDE. Okay, so this is basically an IDE. This is called as a distributor. Okay, Anaconda distributor. And Anaconda distributor that I installed provides this navigator. This UI that you are seeing is called as a navigator, which is like a centralized controlling platform for all the tools that we are installing on top of Python. And mind you, this provides you the flexibility to have multiple Python softwares installed, multiple Python instances installed. That can be done using this environments tab. Okay, you can see towards the left side, there is environments tab. If you click on that, you will see two options. In my screen, you are seeing two. If it is a fresh installation, you will only see one, base root. But always remember, do not directly work with your base root environment. Never do that. Always create a new environment. We call it as virtual environment. So what does this basically mean is I'll have in my system, I have two different Python version softwares installed. Okay, separate versions, independent. There is no relation between them. Okay, I can create as many such virtual environments as the capability of our system is. Okay, so I'll go to my in class because that is the environment that I generally use. It has to be selected, by the way. Okay, if you select, that means you're working on that particular environment. I said I don't want to work with base root, so I'm selecting that in class option. It is now loading that entire environment. Hope everybody is following me. Look, everybody is so silent. Following me, not following. Yeah, Anand, thanks. Others, please. Okay, how many of you are new to this Anaconda? Everybody knows Anaconda? Guys, if you know, please let me know. You are new, okay. Satya is new, okay. Fine. So, yeah, this is the interface. And I've selected this, right? And what happens is every environment that we are creating, right? As I said, it will start with the basic command line interface. But what we do is, if I come to this home section once again here, okay, come here, you see these um, components, right? Individual components, each box that you're seeing has a separate tool or a software. Okay, and each of these tools help us to write our programs in a better way. Basically, it is an assistance, right, to the developers. And there are many softwares that you can choose among this. Not everybody is, I mean, not all tools are independent, but these are basically used in complement of each other. Some of them are like competitors among themselves, right? So on and so forth. But all of these, in fact, are open source. They are separate softwares. Anaconda, what does Anaconda do? They try to connect with those manufacturers, developers, and they try to bring all those softwares at a single place. All these are basically the softwares which work with Python. So the single platform will allow the user to manage everything that can be basically worked along with Python easily. Then slowly more things are getting added to this list. Okay, now if you're using Windows, right, you have Windows command prompt, simple Windows command prompt, right? But here you will see a command prompt which is provided. Now, what is the difference between the command prompt that we get here and the Windows command prompt that we directly get at the OS level? If you take OS level command prompt, so if I want to show you the command prompt in Windows, I'll say CMD. This is the Windows command prompt. Okay. But the environment, it does not know what Python, the software that we are using, right? What Python is installed, what are the capabilities, I mean, what other packages are there in that Python, etc. Because this is not mapped to the Python software. But if I open this, right, if you see, I have something called as Anaconda prompt. That is nothing but the cmd.exe prompt, okay? When you install, you'll get this option. Now, if you look at this, it says in class. This in class is the virtual environment that we've created. So that means here in this command prompt, the operating system will be aware of the Python software that we are working with. Okay, this is important. We'll try and understand why this is important when we go to the packages and all that. Okay, next is the Jupyter Lab or Jupyter Notebook. This is more popular rather than this. Jupyter Notebooks are very popularly used. In all the cloud platforms, this is the interface that is used because of the interactivity that allows you to work with. And this is a web browser based interface, web interface. That means you'll not need any additional software. It uses your browsers, like say for example Chrome or Firefox or Windows, right? Internet Explorer, whatever is the default web browser, it uses that. Now, for the code explanation, I will use spyder. Okay, spyder allows us to have a better interactivity. Right, we will be able to see what is happening in the backend and all that. So interactivity is better in this app. Hence, I would prefer this. But this also is a little heavier. Per se, for the software perspective, this is a standalone application that needs to be installed in your machine. So it requires a lot of resources. But at the learning stage, this is always the best. I would strongly recommend spyder. Now, as you try to get better and better in Python, then Jupyter Notebook is one option, and my system does not have VS Code. Strange. You might also want to use VS Code. Somehow my VS Code is gone. But yeah, we can also use VS Code. Okay, that plugin can also be used. All right. So we will be, as I said, we will be working with spyder. See, these are all external softwares, separate software, not Python. Python is fine, but this is not Python. This is along with Python additional tools. Okay. Now, what happens is if I how do I say? Fine. So among so many different options, which option do you want to actually use, right? Once you choose that, once you decide it, like I said, you'll have to use spyder to start with. If you're in Windows, then install this as well. Okay. So what happens is when you come to the navigator to start with, you will see these install options everywhere. Okay. All these are install. So what we do is we try to get that particular software installed in our machine by just clicking this button. You don't have to exclusively install the software and plug in that to the Python softwares and other things. Not required. That installation and integration of the softwares will be automatically taken care by this Anaconda Navigator. It is a centralized controlling unit. So you just have to click on the install button and it will install the software. And when installation is completed, you will see this launch button. Okay, so install first and then launch. Now you can launch the application from here or directly, once the installation is done, directly you can come here and launch that from here. So you can see spyder and then environment name. So now the code gets executed, code gets loaded. Okay, I mean the app gets loaded. This is how your interface looks like. Now in this interface, there are certain things that we need to understand. The first thing is this section where you will see untitled 0.py. This is the file name. Right now we have not named anything. This is where you write the code. This is also called as scripting pane. Scripting pane. Or we also call it as editing pane. Scripting pane or editing pane. So your entire code is written here. This is like a notepad. Okay, this is like your notepad. Just like you open a notepad, I'll show you. If I open a notepad, what do you see? Untitled, right? At the top, you can see untitled. Same way this one. If you save notepad, it will give you by default the .txt file. Whereas if you save this Python code, it will give you .py. .py as a file extension, Python script. Okay, you write your code. But when you're writing it, you obviously will not execute it. It's like a notepad, right? In order to execute, we will have to select the line that you want to execute and then click on the execute button. For example, I'll say minus this. So if you see, it's like a calculator. I'm just randomly writing some numbers and saying subtract this. In order to execute this line, now what I do is I put my mouse cursor on this line, anywhere on the line, and then I click on this I symbol at the top. You can see, right? It says run selection or current line. In bracket, if you see, function F9 is what it is showing. So we try and execute this one line at a time. And you can see the answer. You ignore this. This is a warning message in my system. Specific to my system, you can ignore that. Okay. So if I run it again, it will again execute. Okay. So what you can see is writing code is fine, but executing it is the another step. So this is a notepad. I can write 1, 2, 3, 4, 5 lines like this. Multiple lines I can keep writing this. 2 multiplied by 56. If I hit enter, I'll go to the next line. Plus this. Right, like this. You keep it entering so that we go to the next line. Like notepad. And when you want to execute, you put your mouse cursor on top of that line and then execute. Either function F9 or this I symbol. Okay. Now, what if I do only this? I selected 2 plus 3. I have not hovered my mouse on that line. Of course, it is on that line, but I've also ensured that I'm selecting specific area of the code, 2 plus 3. So what happens here is when I execute this, only that selected part gets executed. If you observe carefully, only that selected part gets executed, not all. So once again, if you see that message, it says run selection or current line. If you select something, that selected part gets executed. For example, I can select 2 lines and then execute. Okay, not just one line, multiple lines can also I can execute. Okay, all right. You may want to see this, but what happens is when I run like this, whatever is the final output or output of the final line, that gets printed. This 234 multiplied by 56 is not executed here. It does not show here. When I run only one line, it is showing. This is because what happens is when I execute a line, that line goes and sits in the console, this console. Okay, this is again a temporary memory location. Okay, but after this, immediately there is another command. So this computational result will go into the memory, console memory. So it is overriding the previous one and then updating with this and then printing that. Now, if you if you want to ensure that both the lines are printed, then we use a command called print. You write print like this and enclose that value in the brackets after print. Now what happens when I execute? I'll get both the lines. So look at the difference. Okay. You also need to observe one thing. For every line of code that I'm executing, every time I execute something, you would see that sequence number get added here. Okay, this basically is tracking how many things are getting executed in that particular session. Okay, and each execution should be independent. Hence, it keeps a tracker of all these executions. First input, first output. Second input, second output. Third input, third output. Fourth. But look at this fifth. Only one final value is getting printed. Okay. And when I used print command, I don't have out coming here. Only input is given in 6. Out 6 is not given. This is because what print command does is it just directly prints the value which is inside the bracket. So when it is printing this value 234 multiplied by 56, it does the mathematical computation and prints the output. It does not send it back to the kernel saying that, hey, this is what I printed and you print this on the screen, right? Not required. Because print command itself is printing that output. Print does not do the execution, remember. Print will only print whatever is there inside the bracket. Because it is not like an execution directly, you'll not see out button here or out value here. Okay, this one difference you kind of by heart. Remember this. Okay, all right. Now let us see some of these codes which are there. With documentation is also given. I'll share this files anyways. So if you look at this, anything after hash is a comment. Hash means comment. So Python's kernel will treat this as a description, not as a line of code to get executed. So for every line, you can see hash is added. You can have n number of hashes. At least one hash should be there at the starting. If you see hash, that means it's a description. Okay, so variables. Then we talked about built-in data types, right? Standard types. Here we have numbers, sequence data points, and then we will also talk about future operators now. So variables, you can see all the description is also given here. And some examples, x is equals to 10, x is equals to 15.6, a is equals to Python. These are all fine. Okay, they work. For example, so if I say x equal to 10, this variable is getting created. If you say this is sessions memory, I'm trying to store 10 somewhere. That location is represented by uppercase X. Then I am running smaller case X is equals to 15.6. So I'll have 15.6 somewhere. This I am representing with small x. Uppercase X, smaller case X. And then I have Python. This is ABC. ABC is the name, just like X. All right. So all these three are valid, and the beauty is you will be able to see these variables that we are creating in the variable explorer pane. Okay, I talked about only scripting pane or scripting page, which is also called as editor pane. And when the execution is happening in this section, which is called as a console. Okay, you can see IPython console is given here. So this is where the execution actually happens. Then this is variable explorer. All the variables that we are creating, they get stored there. So memory, whatever the memory pointers that we are creating, we will not have any track of it unless until we see here. And remember I said spyder is the IDE that we prefer. IDE is nothing but a graphical user interface which allows the programmers to write programs much easier and conveniently, right? So IDE, integrated development environment. We prefer spyder. I prefer spyder because explaining things becomes much easier here. This kind of a list is not available in VS Code or Jupyter notebooks, right? Not there. Many popular IDEs don't have that. Spyder has it. So I love Spyder. So what happened here when I say x equal to 10, x is the name of the variable which gets created. 10 is integer. Automatically it has detected that and we have only one value there. Now what happens when I say x is equals to 15.6? If I say x is equals to 15.6, what will happen? Yeah. You have to participate, guys. If you're not
I think
participating,
see, this one both are two different variables actually. X is smaller, one
correct.
is capital, right? So it
Very
will
good.
treat as a two different value, and one first one is a 10, second one is a decimal value.
Correct. In Python, the decimal values are called as float.
Float, correct.
So it will say small x float. How many values we have here? 1. What is that value? 15.6. This is what gets updated here. Okay, let me run this. Okay, x float 1, 15.6. Similarly, now tell me, let's see how many of you will tell correct. What will happen this when I run this? Very good. Okay.
That
Very
is
good.
string value.
So I get ABC. This is string. What will be the value here?
Python.
Here, size. 1.
One only, one string actually. Yeah.
Very good. Very good, Nuri. You need to look
That
into that.
single
I
quote.
understood. I understood. If you look at this, it will say that it is 6. The size is what we have to see. Total size, not the index. It talks about the length, wherever it starts. So how many characters are there here? 1, 2, 3, 4, 5, 6, right? 6 characters are there. So total size is 6 characters. Got it? All right. Now, I also mentioned that keywords or reserved words should not be used. They are predefined and we cannot use them, right? So these two lines basically give me the list of all the keywords, keyword lists, okay, that we should not be using. So these are all the words that I cannot use as a variable name. If, in, or, pass, raise, while, with, yield, right? So these bunch of words cannot be used. Any other any other word can be used. Okay, you'll understand this the syntax later when we talk about packages. When we talk about modules, you'll basically learn how do we use them. Okay, so import is basically to load that content. All right. Next, we talk about now the operators. Okay, let me first finish this. Otherwise, there are a few more lines. Okay, this is bus. Again, it is a float value. Right? If I say bus, it will give me the value. Print of bus also will give me the same result. But remember, here you will get out. यहाँ पे, that is in this line, it will not get printed with that out option. When you say print, the out option will not come. Now, what happens when I run this? Bike to us equal to 20. What happens? Why is it invalid? Yes, it is invalid. That's right, Anand. Space. Yes, space is there. Remember English, I spoke about this yesterday, right? English, not yesterday, last class. Space delimiter language. So we write space for every word, isn't it? That means each word has to be treated separately. So that means here I'm trying to have two different variables, which is not accepted. Okay, this is not the right syntax. And you can see this red color cross mark. This is again a code assistance. You can clearly say that there is some issue here. And if you hover your mouse, it says invalid decimal literal. Okay, so some warning message which basically says that it is invalid. Then car dollar. Can I use this? Car dollar is equals to 5 as special character. Yes, have a special character, so it cannot be used. Can I use this? New underscore car? Yes, because underscore is something that is accepted among all the special characters, right? So this is string, 3 characters, CAR. That is the value of that new car variable. What will happen if I say ABC? If I'm just typing ABC and print, what will happen? Yes, what is that value? What is the value of ABC? You can see here. This is the shortcut. No, no, it is not null. ABC has a value here. You can see that. This is the beauty of spyder. In other IDEs, you will not even know that there is a variable called ABC already created unless until you remember it explicitly. You have to remember whatever the right variables you are defining. Otherwise, this is not listed anywhere. Okay, except in spyder. This is with respect to your building blocks. I'll talk about data types now. Primitive data types to start with. So these are basically the integers, right? And this is integer, this is integer. So these are arithmetic operations also that we are performing on integer values. Anything which is not a decimal value is integer. But if I say 11.5, for example, then it becomes a float, right? Let's see this. I'll erase all this. I will load x equal to, see what did I do now? Just now what did I do? I selected all the variables and clicked on this remove all variables symbol. Okay, erased the memory. So I'm freeing up my memory. Okay, now x is equals to 55.45. Did I say that it is a float or did I anywhere mention that it is an integer or anything? No, right? By default, because it is a decimal value, it has automatically taken the value of x as a float type. Okay, now if I say y, then y will become what? If I say a equal to 10, I'll run this a equal to 10. Then a is integer, right? So this way, you would basically try and see that Python, you observe that Python will try and detect the data type. Automatically, the detection happens. Print of x is 55.45. Type of x basically shows that it is float. Here, if I say type of a, then it will say it is integer. Clear? So data types, right? We are basically talking about integer and float. Then this is a complex number where I have integer, real number plus imaginary number. This is the imaginary number and you can see clearly it says complex number. Next, Boolean. Boolean value has only two options, true or false. And remember, Python is case sensitive. So this case is very, very important. We call it as proper case, where T is in uppercase and the remaining characters are in lowercase. And true in Python is represented with 1. Okay, Boolean value is 1. whereas false is represented as 0. Now, why false as 0, why true as 1 is a question. Why not vice versa? Python, remember, is like an English language. So it will always start indexing from 0. This is point number 1, and there it will be sequential from there. Like that means 0, 1, 2, 3 in that order. But this is for numerical values. For non-numeric values, it follows alphabet order. Alphabet order. So that means in true and in false, if you observe the first character, F comes first in the alphabetical order, followed by T. Hence, F gets 0, index 0, and then followed by index 1. But these are default values you have to by heart. You can see type is BOOL. Then the non-numerical data. We call this as character data or sequential data, right? So it is basically characters which are sequentially arranged. There is multiple characters are put together. We call these character data as string in Python. Strings. Okay, strings. String is nothing but a sequence of characters. It could be letters, numbers, special characters, anything. But it needs to be enclosed in any of these codes. It could be single quote, it could be double quote, it could be single double quote, it could be triple double quote, double triple quote, right? Etc. etc. So single quote, double quote, single triple quote, double triple quote. Okay. So anything enclosed in these quotes is considered to be your string data. All right. So if you look at this, you need to also observe the difference between this and this in the string. What is the difference here? Yes, very good. So the difference is, in this case, only the first line is in green color if you observe carefully. The next two lines are in white. This one also. Whereas in this case, sorry?
Yeah, no, sure. That's good.
Okay, all right. So in this case, you can observe that all the lines are in green color. The difference here is the quotes. When you enclose a text inside this single quote or double quote, then these basically are good for one line characters only. They work for single line only. But if your text data is continuing in multiple lines, then you either use this one or this one. These both are for multi-line strings. Okay, so here I'm putting 3 single quotes so that multiple lines can become my string. So what I do now, I will select all and then execute. Because remember, it is multiple lines, right? So spyder will execute only one line at a time, if you're not explicitly telling Python to execute certain set of lines. So I'll have to select all of them and then execute. That gives us this string. A is a string with 216 characters. Of course, this includes the space as well. The space, the commas, right? Yeah, the full stop, the colon. All these are part of your string. So 216 will include these count as well. I mean, these special symbols also. Then you can say print A, everything is getting printed. Type A is string. STR stands for string. Okay, then we have this sequential data types. We will discuss this later. We'll come back to that. Next, we talked about operators. Right? We talked about operators. After the primitive data types, we move to operators. These are the different type of operators that you will see. 1, 2, 3, 4, 5, 6. 7 is there, but we will not really look into that. Okay, and the most commonly used 1, 2. The rest of the things are used, but yeah, rarely. And this identity operator is now kind of mixed into the or merged into the comparison operator itself or relational operator itself. So let us see. Arithmetic operations. As I said, plus, minus, right? All these arithmetic operations are done using this operators or these symbols. We call them as arithmetic operators. This is addition. I'm assigning A and B as 10 and 20 and adding them. So I'll get what? 30. Then I'll subtract, right? A minus B, I'll get what? Minus 10. A multiplied B, 200. A divided by B. Now what will I get? A divided by B. Let's see. 0.5. Okay. Let me show you. 0.5. Now what will I get if I do floor division? This is called as a floor division, double slash. What will I get if I do double slash? Try, anyone. What will I get? No. Floor division, floor. Floor. So it will always give us integer. That is a hint I can give. Yes, easy. So whenever we get a float value, that is decimal value, and if I'm trying to do floor division in that, then it will go to the lower integer. Hence it's called as floor. So the answer is 0 when I execute this. So you can see that it is 0. Okay, now look at this. X equal to 1, y equal to 2. Very good. So I'm first doing regular division 1 by 2. What will I get? 0.5. Then I'm doing 1 by double slash do. What will I get? This one, what will I get? 0. Yes. But now let us see. I'm changing this x to minus 1 and y to 2. And now I do minus 1 by 2 minus 1 double slash 2. What will I get here? Minus 0.5. But what will I get here? 0. How is it infinity? When you get 0.5, you go to what? Floor division, right? Floor, lower value. But now what we are getting? This is minus 1 by 2. So that means to start with, it will be minus 0.5, which is here, minus 0.5. So what is the lowest value? What is the lower value between these two integers? Minus 1. It has to move to minus 1. Okay, let me show you. Look at that. So x1 by 2, if I run this, then you get 0.5. Right? No problem, 0.5. Then I'll run again x double divided by y, I get 0. But yeah, but when I say x is minus 1, y is 2, and if I run this, I get minus 0.5, but whereas this one, it will give us minus 1. Floor division, right? The next one is another type of division called modulus division. What will this modulus division give? Any guesses? Reminder, exactly, reminder. So what will be this response? This is 20 divided by 10. Yes, very good. The reminder is 0. A percentile B. 10 divided by 20. Hmm, 10 na? 10 divided by 20. Reminder is 10. 20 is 10. I'm dividing 10 by 20. So this is 0, 0. The remainder is 10. Okay. Then this double star. This is exponential power. Very big number. A power B. 10 power 20. Okay. So this is basically the big number of zeros that we get. These are your arithmetic operators. Then these are your comparison operators. Very easy. But one thing very important. If I talk about comparison operator, or we also call it as relationship operator, this comparison operator or relationship operators will always give the output, the result in Boolean values only. That means this can be either true or false. That's it. Here we get different results, mathematical calculations, but for comparison operator, it will either be true or false. That's it. So is 10 equal to 20? No, right? Yes, so we get false. And case sensitive, remember F has to be uppercase, and then the next remaining words will be lowercase. You cannot write, you cannot write like this. This is not a valid result. Okay, false is predefined. Okay, you cannot also say false like this. All small cases can also be not taken. This is the right syntax. Remember that. So this is false. A is not equal to B. Yes, this is true. Is A greater than B? No, right? False. A is less than B. Yes. A is greater than or equal to B? No. A is less than or equal to B? Yes. Okay. Now this is interesting. So we already have spoken about assignment operator, right? I gave this example. This equal to symbol is called as an assignment operator. So now what we're doing is kind of bringing the assignment operator plus arithmetic operator together. This is used as a shortcut for many operations while we are writing big scripts, right? These kind of syntaxes are used as a shortcuts. So here what you see is C is equals to A plus B, right? This syntax, C is equals to A plus B. So A is 10, B is 20, and we are saying C is 30 because we are adding these two. Okay, A plus B. Now look at this syntax. We are saying C plus equal to B. So now this basically means this. C is equals to C plus B, which basically says perform the arithmetic operator, but assign that back to C. So it is C equal to C plus B. Okay, so that is how we write this syntax. C plus equal to B. Same way we do it with minus, star, division, modulus, power, floor division. All the arithmetic operations can be performed using the symbol. So here if I say C plus equal to B, C is already 30, remember. C is 30, A is 10, B is 20, right? C is 30 here. Now when I say C plus equal to B, it says C is equals to C plus B. So here it is 30 plus 20. This new value gets updated into C. So C becomes 50. You can see here. I'll run this. So C is 30, getting 30. Right? Now I will say C plus equal to B, it becomes 50. And again I subtract B, I'll get 30 back. Then multiply 600, divide, you get 30. Now one thing, before division, the value was integer. Okay, the value is integer. You can cross check. I'll show you once again. I'll erase all this. Where is A equal to 10? Equal to 10. Okay, A equal to 10, B equal to 20. I'll say C is equals to 30, right? So you can see these are integers. Then I'll do this addition. It became 50 integer. It comes back to 30 integer. And multiply, it becomes 600 integer. But as soon as I do this division, now look at this, it changes to float. Because in all these three operations, the data type will not change. Right? If I'm multiplying with integers, integer will be the output. If I'm multiplying with float, values will be float. Data type does not change with these three operators. But when I do division, there is always a chance that I might get a fraction or a float value, right? A decimal value. Now what happens is Python treats float as the default data type. Why? Because I can have 30, right? I can have 30 represented at 30.0. That means integer can be represented as a float. This is the higher order form. But can I represent 30.2 as 30? Can I change the float value to this integer? No, right? That means data loss happens. So Python is intelligent enough to understand that float is the higher order data from which can be also used to represent integer values. But the other way is not possible, right? So default data type for numeric values is float. So as soon as it says this division, it automatically changes the data type to float. Whether you get decimal value or not, it will assign space for it because there's always a scope. Okay, so there's one more point that you need to remember. Then modulus division, 10. Then we have power. Now, what is this? 1e plus 20. What is this number? This is again a shortcut to represent very, very large numbers. Okay, very large numbers. It's not not complex, but it's a very large number that we try to represent this way, shortcut. This is 1 into 10 power 20. E is nothing but exponent, power. Okay, that is basically the representation of this large number. Because we are doing power, right? This is what? C is equals to C power B. What is C? C here we obtained before this. C is actually 10, 10.0. And B is 20. That's what we are writing here. Okay, so that is arithmetic operator, and this is the floor division. Floor division, remember, is coming to the lower integer form. 5 into 10 power 18. This is the form representation. Okay, clear? All right, next we have something called as a membership operator. Like you have seen, right? Membership. So if I have a set of numbers, for example, or a set of data points, then I want to see if a single entity or a smaller entity is a subset, is a member of this or not. That's what membership operator is all about. Again, this membership operator will also give you Boolean output because here also we are only checking whether it is part of this or not. That's it. So in this case, we are saying main string is Python. Is the substring Y part of this or not? What will be the answer? Is Y in Python? Is it there? Yes, right? So we'll get true. Is L in Python? No. False. Is P in Python? P is there in Python, but case sensitive. This P is small case, this P is large case, uppercase. Okay, what will be this? P not in Python. Yes, this is again false because this P is present. So it should be P in Python would be the right option. That basically should give you true. But now you're saying P not in. So we are saying no, it is there. Hence, this statement will be false. Very good, very good, very good. Others, please participate, guys. Yeah, I don't see you participating. Okay, this is a different case. I'll not talk about this. because we did not discuss about list, right? I'm not explaining this. Then we have identity operators. Identity is like your comparison operator only. And here we have is and is not. In the membership operator, we have in, not in. Here it is not. Okay, so these two syntaxes, but these are deprecated. You will see a warning message. I'll show you. Why is Python? Look at this syntax warning. Right? It says, did you mean double equal to? Right? So the answer is anyways false, because y is not Python. Python is Python. Is 1? Yes. The answer is true. Is 2 is 1? No. So it is a false. Is Python? Again, no, because this is lowercase, this is uppercase. It is false. This is also false. And is 1 is 0? No. Is 1 not in? Is not 1? Then this is also false, because 1 is equal to 1. Okay, so this is not. We are not checking whether it is equal to right, is same or not same, right? So we are saying it is not same, and yes, they are not same. Hence, it says true. Okay. Now, finally, the last topic for the day is the order of execution. Very, 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 very important. Whenever we do these arithmetic operations, right, I want you to tell me what will be the value of this. Arithmetic operations are very important because the order of execution is super important. So 2 plus 3 multiplied by 4, right? See, everybody is giving me different answer. 14, 15, 14. So if I add these two, I'll get 5 multiplied by 4. What am I getting? I'm getting 20 here. Then I have 2 plus 3 multiplied by 4. First, if I do this, then 2 plus 12, I'll get 14. Right? So which one is right? Is this right or this right? Like you guys have calculated, 14 is the correct answer. Why? Because the order of execution is important, and this is the shortcut to remember. PEMDAS. Parenthesis, exponent, that is power. Then we have multiplication. D stands for division. Addition. And finally, we have subtraction. So in this case, here, yes, we are saying this is 14. But what about this? This becomes 20 because parenthesis is given here. So first I'll have to execute this only. What about this? Yes, 2 power 3 multiplied by 4. So after parenthesis, the second importance is given to this exponent, power. So 2 power 3, 2 cube is 8. 8 fours, right? 32. And finally this one. Division, addition, subtraction. 6 by 2, 3. 3 plus 3, 6. 6 minus 1, 5. Right? So same order we will follow. And because it is division, this is float, remember. Okay, all right. So this is basically the end of the class for today. We talked about variables, we talked about primitive data types, and we talked about operators. Tomorrow, I will be giving you a quick glance over these sequential data types. Okay, these are all called as sequential data types. Here we have sequential data types, right? I'll not deep dive into this, but we will just you have a high level understanding about what are these additional data types that we need to look into. We'll have a different section where we will detailedly understand these data types. So that is something that we will start tomorrow. Clear? Any questions? Pretty simple, right? English, more like English. All right. So I'll see you all tomorrow then. Thank you. Yeah. Thank you. Good night.